find the sum of the first 8 terms, so the sum of the first 8 terms of the geometric sequence, where the first term is 3 and the common ratio is 2. Now, first of all, we got to know what a geometric sequence is. So a geometric sequence, you can think about it as a sequence of numbers. So it's a sequence of numbers where you're multiplying each term by some common ratio. So take a look at this sequence right over here. Notice how to get from one term to the next term, we have to multiply by 2. So in this case, 2 is going to be our common ratio. And this can go on forever. So 16, 32, and then you can just keep going on forever. So right now, we want to find the sum of the first 8 terms of the geometric sequence, where the first term is 3. So if the first term is 3, and the common ratio is 2, meaning that to get from 3 to the next term, I would multiply this by 2. So my next term would be 6, then the next term after that would be 12, because 6 times 2 gives me 12, then 24, 48, and so on. And I want to find out the sum of the first 8 terms. So if I listed out all 8 terms right over here, and I added all of them up, what would I get? Well, a lot of you would be like, I don't know. I'm a little too lazy to do that, and this is very annoying to do. And this is why there's actually a formula for this. So if you want to find out the sum up to the nth term, right? So let's say if I want to find out a sum of a sequence, so sum of the first 8 terms of sequence in this case, this is going to be equal to the first term times, it's going to be quite a handful, so prepare yourself. So this is going to be equal to 1 minus r to the nth power over 1 minus r. R in this case represents our common ratio. So I'm just going to write CR, it stands for common ratio. N represents the term we're trying to, kind of the term we're on. So this represents the term we are on. So let's use this formula to find out the sum of the first 8 terms of this geometric sequence. So my first term, a sub 1, is equal to 3. So it's going to, my sum, in this case, we're trying to find the sum of the first 8 terms. So I'm just going to replace the n with 8. So I'm going to find out the sum of the first 8 terms. My first term is 3. This is going to be 1 minus my common ratio. My common ratio is 2. And it's going to be raised to the nth power. The n just represents the term we're on. So in this case, we're trying to find out the first 8 terms. So instead of this n right over here, I'm just going to put an 8. So it's just the term we're on. And then this is going to be divided by 1 minus the common ratio. We said that was 2. And if you put this into your calculator, you're actually going to get 765. And yes, this is the correct answer. If you actually wrote out all 8 terms, so after 48, you're going to have 96. After you have 96, you're going to have 192. After, so 1, 2, 3, 4, 5, 6, 7. So you're going to have one more term. This is going to be equal to 300. Let's see. So 400 minus 16, it's 384. All right. And it turns out that if you add all of these terms up right over here, you're actually going to get 765. And that seems pretty believable right here. Now, a lot of people get confused with the geometric sequence formulas. So this formula right over here we just used is to find out the sum of all of these terms, right? We're trying to find out the sum of every one of these terms. However, for this geometric sequence formula right over here, this is only used to find out the nth term. Let me show you what that means. So for example, let's say if I wanted to find out the 8th term of this sequence. Well, what I would do is I would say, okay, my 8th term of the sequence is going to be equal to my first term, a sub 1, my first term is 3, times my common ratio, r, so in this case 2, to the n minus 1 power. Since I'm trying to find the 8th term, my n value is going to be 8. So it's going to be 8 minus 1, which is 7. So 2 to the 7 is equal to 128. And 128 times 3 is equal to 384. So this is going to be equal to 384. Notice how this 384 matches up with this 384 right over here. Right? This is the first, second, third, fourth, fifth, sixth, seventh, 8th term of my sequence. So now, maybe now you start to realize the difference between these two formulas. This formula right over here is just giving you a single term. All right, this formula right over here is just giving you the nth term. It's just giving you a single term out of this sequence. However, this sum formula gives you the sum up to that term for this sequence. So that's the difference between these two formulas. One gives you the sum, one just gives you one single term. All right, so don't get confused with these two formulas. Now, I'm just going to use the same thing because I'm too lazy. Let's say if we have 40 terms. Let's make this tricky. Let's say if my first term is 2 and my common ratio is 1/2. How would I do this? Well, if I want to find out the sum of the first 40 terms, well, once again, I have to use this formula. So the sum up to my 40th term, sum of all the terms, including my 40th term, right? That's going to be equal to my first term. We said how my first term is equal to 2, right? It's going to be equal to a sub 1, which is 2 in this case, times 1 minus the common ratio, right? Common ratio, which is 1/2. And it's to the nth power, which is the term we're on. So the term we're on right now is 40. So it's going to be 1/2 to the 40th power. Just make this a little clearer. And then divide this by 1 minus 1/2, right? 1 minus r. Now, this one, you have to use a calculator. So this is going to be this. 1 minus this. 2, 1 by 0, 0.5, and it's going to be equal to 4. So this is going to be approximately 4. All right. And that's going to be our answer.